All right, 7.4, we're going to talk about adding and subtracting radicals. Okay, so here are our steps. Simplify all the radicals. Anything that can be simplified, simplify it. Then we're looking for things that have the same index, which means the same root, and the same radicand, so the same number underneath. So what we're looking for, same index, same radicand, that is another way of saying like terms. Okay? And then, just like we've done for other like terms, when we add and subtract, we're going to add and subtract the coefficients, but we're going to keep the radical the same. It's not going to change. Okay? So, here, 3 square root 6 minus 2 square root 6. Okay? The square root of 6 cannot be simplified. There's no perfect square I can divide by. So, I'm going to subtract the coefficients. 3 minus 2 is 1. So I have 1 square root 6. Normally we don't write 1 as a coefficient, so you're probably going to see that written as square root 6. The square root 6 stays the same, okay? Just like if you had 3x minus 2x, that would just be equal to x. All right, we subtract or add the coefficients, and then the number inside stays the same. Okay, so like this one here, square root of 5 cannot be simplified. All right, but these are the same, so I can add them together. So 2 plus 2 equals 4 square root 5. All right, now a lot of times we have to simplify first. So here I have 10 square root 7. Okay, the square root of 7 is simplified. So I'm going to go ahead and copy that down to the next row. Okay, the square root of 63. Okay, 63, the perfect square that it can be divided by is 9. If you like the tree method, that's fine. You can do that too. Okay, so I'm going to break this apart as 2 square root 9 times square root 7, because 9 times 7 gives me 63. Okay, that means that this root now can be simplified. So I have 10 square root 7 plus 2 times, the square root of 9 is 3 times square root 7. All right, so 10 square root 7 plus 6 square root 7. Now, these are like terms. They're both square roots and they're both 7s. So I can add the 10 and the 6 together and I get 16 square root 7. All right, then skipping down to the second page, let's look at what happens when we have more than two terms that we're adding together. So, square root of 10 cannot be simplified. Square root of 6 cannot be simplified. Square root of 10 cannot be simplified. Okay, so what can I combine? What are like terms? Well, the things that have square root of 10, those are like terms. So negative 2 minus 2 is negative 4 square root 10. Okay, then what do I do with this negative 3 square root 6? The answer is nothing. It cannot be combined, so I just bring it down. And this is as simplified as that expression gets. Okay, because I can't put these two together because these are not like terms. This would be like if this was x and y. Okay, different number under the square root means nothing to be done. Okay, so let's do a big complicated one where we got to do some simplifying. Okay, all right, so negative 3 square root 50. Okay, biggest square perfect square I can divide that by is 25, so it'd be 25 square root 2. All right, the square root of 18 I can break apart as the square root of 9 times the square root of 2. And then the square root of 3 cannot be broken apart, so I'm just going to leave it for now. Okay, so let's simplify the perfect squares that we have. All right, so this is now negative 3 times 5 square root 2 plus 3 square root 2 minus 3 square root 3. Okay, negative 3 times 5 is negative 15. And I'm just copying the rest. Okay, now what are my like terms? The things that have the same root. So negative 15 square root 2 plus 3 square root 2. All right, negative 15 plus 3 is negative 12 square root 2. And then minus 3 square root 3 because there's nothing I can do with that. And that would be my simplified answer. Okay, so 3 steps. Simplify, find your like terms, combine them. All right, and that's how we add and subtract radicals.